P. Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSE, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. This series of lectures cover about mobile and pervasive computing. The lecture series cover cellular wireless networks, global system for mobile communication, GSM architecture, GSM protocols, connection establishment, frequency allocation in GSM network, GSM handover, security in GSM, and the general packet radio service, that is GPRS. Today's content is about frequency allocation. In the previous lectures, we have discussed about the connection establishment. The mobile station is making a call to some other mobile station or to some other fixed stations in PSTN networks. So, the radio channels has to be allocated between the radio user to the tower, and from the tower to the next destination station, the connection has to be established. So, in the today's lecture, we will learn how the frequencies are actually allocated for the channel. Before learning about the frequency allocation, we should know about the spectrum. What is a spectrum? Spectrum refers to a collection of various type of electromagnetic radiations of different wavelengths. A spectrum is a collection of various kind of waves. So, individual wave may have its own frequency as well as wavelength. Spectrum or airwaves are the radio frequencies on which all the communication signals travels. The data is represented in the form of signals, and the signals now carries the actual data between the source and destination. So, the frequency has to be allocated to carry the data. Frequency and wavelength are inversely proportional. If the frequency is very high, the wavelength of the particular wave will be low. So, vice versa it is applied. Wavelength and frequency of waves decide the nature of the wave. Individual wave has its own wavelength and frequency that specifies its own character. For example, if a wave is with a very minimum of wavelength, it cannot be travel over a larger distance. If a particular wave's frequency is very high, then obviously the bandwidth will be high. So, some of the wavelengths, for example infrared, they have the nature that they cannot be operated without line of sight. So, LOS is mandatory for infrared signal. So, depends on the frequency and wavelength, the characteristics of the wave is defined. This is the electromagnetic spectrum diagram. Here we can locate various kind of waves. So, radio waves, microwaves, infrared rays, visible rays, ultraviolet, X-ray and gamma rays. Here the wavelength is represented in meter and the frequency is represented in hertz. The wavelength is decreased from radio wave to gamma wave, but in case of frequency it is in reverse manner. So, the frequency of radio wave is very less when compared with the frequency of the gamma ray. And visible ray is one which is used in the fiber optic communication. Also the microwave and the infrared rays are located with the various kind of wavelength and meters. The fact is communication channel carries the data. So before allocating the frequency, we should know what is a data. So data is divided into two types, digital data and analog data. So digital data is nothing but zeros and ones used in our computers or mobile phones. We have two type of signal. So digital signal and analog signal. So signal is nothing but the represent of data. Now how to transmit the data over the signal? So we are learning that how the frequencies are allocated to the channels. The main objective of allocating the frequencies to the channel is to carry the data. So how to carry the data? So signals are used to represent the data actually. So we have four type of signal representation methods. Sometimes they are referred as modulation schemes. The analog data can be modulated into analog signal. The digital data can be converted into analog signal. The analog data can be converted into digital signal, as well as the digital data can be converted into digital signal. So these modulation schemes are chosen based on the different applications and the available medium. Spectrum is collection of radio frequencies. Now the radio frequencies are used for different kind of services. They include space communication, mobile communication, broadcasting, radio navigation and defense communication. So now we are in the mobile communication platform. So GSM is nothing but a standard which follows mobile communication. So the frequencies are allocated to the GSM users. We have discussed about the spectrum and the nature of waves. Based on the frequency and wavelength, the nature of the waves are defined. Now let us start our discussion that how the frequencies are allocated to the GSM users. In GSM, mobile users are connected to the GSM network through the radio interface. So in the previous lectures, we learned about the radio interface or air interface, that is referred as UM. The UM now takes the responsibility of connecting the mobile users to the fixed tower. So many protocols has been defined in the UM interface. Now the UM interface regulates the user to connect with the fixed network. The radio channels are to be assigned with certain frequencies to connect the user within the network. So I am stressing the word with certain frequency. So the frequency is a scarce resource. It has to be handled properly to effectively use the frequency spectrum. Now various authorities, for example, the GSM frequency bands are designated by I2E. So various authorities like International Telecommunication Union, they are the authorities, they allocate the GSM frequency bands in different countries. Now the radio interface UM comprises mechanisms for multiplexing and media access. We will discuss the media access later. Now multiplexing. So multiplexing is nothing but combining many frequency bands together. The GSM implements SDMA using cells with the BTS and assigns the MS to the BTS. So SDMA is nothing but space division multiple access. Now using the sectorized antenna, the SDMA is implemented. So GSM using MAC that combines TDMA and FDMA. So time division multiple access and frequency division multiple access are combinedly used in the GSM network. We will see all the technologies now. Before allocating the frequencies to the channels, it is mandatory to know about the MAC protocol. So MAC is nothing but some set of rules and regulations that specify how to connect the mobile user with a fixed network. The medium cannot be dedicatively allocated to individual users in GSM network. So dynamically based on the demands from the user, it has to be allocated. So MAC specifies that rules. MAC is implemented in the second layer, that is MAC is implemented in the data link layer. Already the data link layer is responsible for flow control, error control. Now the MAC is a part of the data link layer. The major classification of the MAC protocol in GSM are space division multiple access, frequency division multiple access and time division multiple access. We have the fourth multiple access, that is referred as CDMA, that is code division multiple access. As GSM is not directly involved in the code division multiple access, we are skipping that. The MAC says some rules how to connect the air medium. Now, the design of the MAC or the implementation of the MAC in the GSM is quite complex, because the MAC of the wired protocol cannot be directly used in the wireless environment. So, MAC protocol of wired medium, for example Ethernet, that standard is IEEE 802.3, that MAC protocol cannot be used as it is in the wireless medium. So, we have certain reasons. The famous reasons are hidden terminal problem and exposed terminal problem. So, what is a hidden terminal problem? In the wired protocol, we assume that we are able to measure the voltage level of all the nodes connected to that medium. Best example, the Ethernet cable. So, many systems are connected with the Ethernet cable, and individual system is able to identify the voltage level. So, the medium can be measured, the signal strength in the medium can be easily measured by the network interface card. So, in the wired medium, if a system is willing to send the data over the Ethernet cable, first it will assess. The moment it is trying to send the information over the medium, if someone is already transmitting the data, the particular system will wait. So, this kind of channel measuring mechanism is very easy in the wired network. But in case of wireless, it is entirely different. You just consider a scenario, the A and B are the two mobile terminals, they are connected or they are in the range. Now, the third terminal C is connected with the B. So, we are assuming that A and B are connected, B and C are connected, but A and C are not in the range. So, this is the given situation. Now, if A is sending some data, it will measure the signal strength between A and B. So, A will think that the medium is free and it will start sending the information. As A is not in the range of C, C also will try to send the information to the B terminal. So, this is the point where the data is overloaded or the data is collapsed or the data is lost in the terminal B. So, this is known as hidden terminal problem. Now, in the case of exposed terminal problem, you consider the same scenario, A and B are in the range, B and C are in the range. Now, B is transmitting some information to C. As B and C are in the range, they can be communicated. But A wants to send information to some other terminal. But now, as B is sending some information to C, A will not be able to send the information to some other node. So, unnecessarily the B is exposed to the terminal A. So, these kind of hidden and exposed terminal problems has to be handled properly in case of MAC. So, the MAC design in the GSM stand is a complex one. So, we have learned about the MAC protocol. Now, the first implementation is SDMA, that is Space Division Multiple Access. The SDMA allocates separate space to users. So, using the sectorized antenna, the space is now divided for different users. The SDMA assigns an optimal base station to a mobile user. Now, the SDMA ensures the best or the optimal base station to be allocated with the GSM user. The mobile phone may receive several base stations with a different quality. The SDMA technology assigns the best base station to the mobile user. MAC considers the available frequencies and the time slots are still available. So, based on the available frequency, it will allocate the base station. And SDMA is never used in isolation. So, in the GSM network, the SDMA access mechanism is never used in isolation. So, after sectorizing the area, the GSM network will use TDMA as well as FDMA to serve the users. So, SDMA algorithm is formed by cells and sectorized antennas. This diagram explains about the space division multiple access. Here S1 and S2 are the spaces, and in this diagram we have three other factors, frequency and time as well as code. Now, K1, K2, K3 up to K6 are the channels. Here the channel K1 is allocated with the space 1 and channel K2 is allocated with the space 2. Like that, different channels can be allocated with the different spaces. So, the SDMA is not used in isolation, instead it is used with the TDMA and FDMA. Let us have a short break. Let us continue our discussion after the break. Welcome back. Before the break, we were discussing about the MAC layer and the space division multiplexers. Let us continue from the frequency division multiplexers. In the frequency division multiplexers, the frequency band is divided. So, many users can be connected with a tower. In GSM, many mobile users can be connected with the tower using radio channels. Now, it is very mandatory one to divide the frequency spectrum to handle the users properly. So, frequency division multiplexers allocates frequencies to the transmission channels. Allocations can be either fixed or dynamic. So, GSM does not provide the pure form of FDMA, that is, the frequency band is not allocated to a particular user always. But in case of pure FDMA, so many examples we have. For example, some radio stations may be allocated with a particular kind of frequencies always. So, that is referred as pure FDMA. But GSM allocates the frequency band to the users based on the demand. In the GSM network, the frequency division multiple access is combined with the time division multiple access and it is used. This is the diagram that explains the frequency division multiple access. Now, K1, K2 up to K6 are the channels and this is the timeline and this is the frequency line. Now, in the diagram we can understand that the frequency spectrum is divided. So, this is the channel 1 that is allocated with K1. This is the second band allocated with the K2. Like that, this is the sixth channel allocated for K6. But this diagram is the pure form of FDMA. We know that the GSMA is not using the pure FDMA. So, the third medium access control mechanism is time division multiple access. The TDMA allocates certain time slots for communication. So, channels are given a whole bandwidth for a certain amount of time. So, here actually the time slots are allocated for the GSM users. Throughout that allocated slot, the user can avail the entire or the allocated frequency band. So, here the timeline is sliced. So, all senders use the same frequency in TDMA, but at the different points in the time. So, we can compare this to the road transport system. Here, all the users are using the same road at different time slots. For example, if car A is traveling the location in the road at one time, for example T1, at the next moment some other vehicle may occupy that portion. So, this is how we are dividing the time slots. This diagram explains the time division multiple access. Here, we can understand that the frequency spectrum or the frequency band is not divided. So, the entire frequency is allocated to the channels, but with a different time slots. So, the timeline is now divided into time slots. For example, in the diagram, K1 is allocated with the first band at T1, as well as K2 is allocated with the entire frequency band at T2. So, all the channels will be allocated with the entire frequency spectrum, but not at the same time. We remember that the GSM network combinedly using the frequency division multiple access as well as time division multiple access. This diagram explains how the frequency division multiple access and TDMA are mixed. Here, K1 to K6 are the channels as usual, and this is the frequency line and this is the timeline. Now, in the diagram, both the frequency band as well as the timeline is sliced. So, for example, this is the portion. Here a mobile user is allocated with the channel, but not the entire portion at the particular time. So, both the frequency band as well as the timeline is sliced and allocated to the many GSM users. So far we have learned about medium access control protocol and various access control mechanisms that includes space division multiple access, time division multiple access and FDMA, that is frequency division multiple access. Let us continue our discussion with the channels actually allocated to the various GSM standards. GSM has two frequencies to be assigned. So, one frequency is known as uplink and downlink. Sometimes they are referred as uplink channel as well as downlink channel. So, uplink channel is one which is established from the mobile station to the tower or base transceiver station, as well as download is a channel that is established from the tower to the mobile station. So, we remember that GSM offers many standards. So, the standards are differentiated among them using the frequency bands allocated. GSM 900, GSM 1800, GSM rail. So, GSM 1800 is also referred as digital cellular system. This is the spectrum allocation of the GSM 900 standard. So, this is the tower and this one is the mobile station. Now, the red ellipse indicates the range of the tower. Now, the downlink channel is allocated with the frequency from 935 to 960 MHz, and in the GSM 900 the uplink is allocated with the frequency band of 890 to 915 MHz of frequency. So, here in the diagram we can understand that individual channel has the capability of 200 kHz. This is the spectrum allocation of GSM 1800. Here the downlink is allocated with a frequency range of 1805 to 1880 MHz, as well as the uplink is allocated with a frequency of 1710 to 1785 MHz. So, now we can discuss more about the GSM 900 frequency allocation. So, in GSM 900 for the downlink 124 channels are allocated as well as 124 channels are allocated for the uplink also. So, individual channels are with a capacity of 200 kHz. The 20 MHz space is provided. Actually, this is the space provided between the frequency spectrum between the uplink and downlink of GSM 900 standard. Let us learn some facts about GSM 900 and its frequency allocation. The frequency allocation scheme for GSM is fixed and regulated by the corresponding national authorities. The uplinks are allocated with a band between 890.2 to 915 MHz and downlinks are using 935.2 to 960 MHz. According to the frequency division multiple access, the base transceiver station allocates certain frequency for uplink and to the downlink. So, here in GSM 900 the duplex channel is allocated. We will learn what is a duplex channel. FDM is another one term, that is frequency duplex multiplexing. So, here the channel should be allocated or assigned between the mobile stations. So, we already learned that uplink is connecting the mobile station with the tower as well as downlink is connecting the tower with the mobile station. So, at the same time two channels has to be allocated. Now, FDM is the method used to allocate the duplex channel. So, two-way communication is referred as the duplex. So, the two entities or two mobile stations or general two stations typically establish a duplex channel, that is a channel that allows for simultaneous transmission in both directions. So, the duplex channel ensures the simultaneous data transmission in both directions. The two entities and their frequencies are separated using different frequency bands. We learned that GSM is mixing the time division multiple access with the frequency division multiple access. Let us learn. So, GSM 900 TDMA frame. So, a frame is again subdivided into 8 GSM time slots where each slot represents a physical time division multiple access. So, the TDM channel and it lasts for 577 microseconds. Each TDM channel occupies 200 kHz carrier. Data is transmitted in small portions called bursts. So, In GSM network, the users are sending their data in terms of small bursts. So, individual bursts has its own frequency as well as own time slot. So, in total, including all the uplink and downlink channels, we have 248 channels. So, the 248 channels is additionally separated in time using the GSM TDMA frame. Each 200 kHz carrier is subdivided into frames that are repeated continuously in the timeline. The duration of individual frame is 4.615 millisecond. So, this is the diagram that explains the GSM TDA frame and the time slots and the bursts. Now, this is the frequency line and this is the timeline. Now, the first portion is nothing but the channels allocated for uplink. So, we have 124 channels in the uplink as well as we have 124 channels in the range of 935 to 960 megahertz in downlink. So, you remember that individual channel has the capacity of 200 kilohertz. Also, the uplink and downlink channels are separated by 20 megahertz band. Now, this is the portion of a time slot. So, GSM TDMA frame, this is referred as the GSM TDMA frame. Now, 4.615 milliseconds is the duration of a single GSM TDMA frame. Further, the GSM TDMA frame is divided into 8 slots. Now, this is the third slot we are taking for our discussion. Now, the third slot is divided further like this. So, that is known as GSM time slot. It is also referred as normal burst. Here, the duration of this is 577 microsecond and it includes guard space and tail, user data, training and the bit S as well as tail, user data and guard space. Now, the guard space is one which ensures that two GSM time slot bursts are not overlapping, and tail is one which is helping the receiver to improve their performance. So, synchronization is achieved using the tail, and user data is nothing but the actual payload or the actual data to be transmitted. So, S is 1. Now, the bit the S is used to differentiate whether it is the data, user data or the network control data. So, the single bit S is used to differentiate that, and training. So, GSM TDMA frame format using training bits. Now, these training bits are used to withstand with the multipath propagation. We remember that GSM users are connected through the wireless medium. Now, the effect is known as multipath propagation. The data originated from the mobile station to some other stations, or the data originated from some stations to the mobile station, are traveling in different type of paths. So, the data will be transmitted in out of sequence also. So, that kind of multipath effects has to be handled properly. Now, the training bits are used to handle that. Let us summarize what we have discussed. Frequency division duplex is used to separate downlink and uplink channels. In GSM, media access combines TDMA and FDMA, that is time division multiple access and frequency division multiple access. In GSM 900, 124 channels are used for uplink and 124 channels are used for downlink, where the individual channel has the capacity of 200 kHz. In GSM, the space division multiple access is not used in isolation. The GSM combines time division multiple access and frequency division multiple access. GSM normal burst is able to identify the user data as well as network control data. GSM time frame is able to manage the multipath propagation effects of data transmission. Let us pose some questions for our understanding. What is an electromagnetic spectrum? Explain the relationship between frequency and wavelength of a wave. Define bandwidth. Why does MAC required in GSM? What is frequency division multiplexing? Can we use the wired MAC protocol in wireless medium? Explain the hidden and exposed terminal problem. Explain the GSM TDMA frame structure. Why does GSM combine TDMA and FDMA? differentiate uplink and downlink channels. With this, we can conclude our today's lecture. We shall continue the remaining facts about the GSM in the forthcoming lectures. Thank you.